Good afternoon. This is our second class of thermal power plant engineering. Okay, this is our second class. Previous day we have discussed about Rankine cycle. Today we discuss about mean temperature of heat addition. Mean temperature of heat addition, mean temperature of heat addition. Mean temperature of heat addition. Okay. Mean temperature. So first one you draw the TS diagram. Draw the TS diagram. Okay, 1, 2, 3, 4. Numbering 1, 2, 3, 4, 5, and this one is the 6. Okay, this is the diagram 1, 2, 3, 4, 5. Okay, the cycle like that. Okay, so the mean temperature of heat addition, actually mean temperature of heat addition here Tm1, that is the mean temperature of heat addition. This is the Tm1. So Tm1 is the mean temperature of heat addition. Q1 is equal to H1 minus H4. Okay, this is your temperature, this is your entropy. Okay, Ts. Q1 is equal to H1 minus H4, that is equal to Tm1 S1 minus S4. Tm1 S1, Tm1, why Tm1? Tm1 is the mean temperature of heat addition, S1 minus S4. Okay, তাহলে Tm1 H1 minus H4, that is equal to Tm1 S1 minus S4. Tm1 mean temperature of heat addition is equal to H1 minus H4 divided by S1 minus S4. Okay, S1 minus S4. Since Q2, that is the heat rejected, Q2 is equal to heat rejected, that is equal to H2 minus H3 equal to T2 S1 minus S4. T2 S1 minus S4. Okay, S1 minus S4. So efficiency of the Rankine cycle, efficiency eta Rankine equal to 1 minus Q2 by Q1 equal to 1 minus Q2 by Q1, তাহলে T2 S1 minus S4 divided by Tm1 S1 minus S4. Tm1 S1 minus S4. Okay, তাহলে Tm1 S1 minus S4, তাহলে that is equal to 1 minus T2 by Tm1. তাহলে that is equal to 1 minus T2 by Tm1. Very very important formula. 1 minus T2 by Tm1. 1 minus T2 by Tm1, where T2 is the temperature of heat rejection. T2 is the temperature of heat rejection. T2 is the temperature of heat rejection. Okay, তাহলে T2 is the temperature of heat rejection. The lower is the T2 for a given Tm1. তাহলে lower is the condenser pressure. The higher will be the efficiency of the Rankine cycle. So efficiency of saturation pressure corresponding to the temperature. Efficiency of Rankine cycle, efficiency eta of Rankine cycle equal to efficiency of Rankine cycle function of Tm1 only. Okay, very very important thing. তাহলে efficiency of Rankine cycle is equal to function of Tm1. Okay, function of Tm1. Now the effect of superheat. Okay, effect of superheat. The effect of effect of superheat. Effect of superheat হচ্ছে the effect of increasing the initial temperature at constant pressure on cycle efficiency is shown is the diagram. Okay, তাহলে first one you draw the diagram. TS. Okay, now draw the diagram first and then we discuss. Two prime, 3, 4. That is the 3, 4 and that one. So this is the TS plot. Effect of superheat on mean temperature of heat addition. So effect of temperature of heat addition. Okay, effect of superheat in mean temperature on the mean temperature of heat addition. So first one, the effect of increasing the initial temperature at constant pressure on the cycle efficiency when the initial state changes to 1 to 1 prime. Is a superheat 1 to 1 prime changes. Tm1 between 1 to 1 prime is higher than Tm1 between 4 and 1. তাহলে Tm1 between the 1 and 1 prime because area increasing, so Tm1 is greater than. তাহলে Tm1 between 1 and 1 prime, Tm1 between 1 to 1 prime is greater is greater than Tm1 between 1 to 1 prime is greater than Tm1 between 4 and 1. Okay, Tm1 between 4 and 1. So increase in the superheat at constant pressure increase the mean temperature of heat addition, hence the cycle efficiency increases. Okay, cycle efficiency increases. Moreover, with increase in superheat, the expansion line of steam in the turbine shift to right. Okay, so increase the overall temperature difference, resulting in reducing rather than increasing the cycle efficiency. Okay, now another one thing, the effect of superheat. Another one is the effect of inlet pressure. Very important thing, effect of inlet pressure. Effect of inlet pressure. Effect of inlet pressure. তাহলে first one you draw the diagram. Temperature, entropy. Okay, effect of inlet pressure, temperature, entropy. 1, first one you draw the diagram first, then it will be easier to you. Now phi 1, this is the temperature T1, that is the 5, that is the 1, that is the 2, 6, okay, that is the 2, 6, another one is the 3, 4 and 7, 3, okay. Another one is the first one is the 3, okay, 3, 4 and 7, okay, like this arrow indicate like this, okay, this one. Now this is your T1 pressure, this is your T2 pressure, okay. Effect of inlet pressure. So the maximum temperature of steam that can be used is fixed from metallurgical consideration, that is the material used for the manufacture of the component which are subjected to the high pressure, high temperature steam, like the superheater, valves, pipeline, inlet stages of the turbine and so on. It is called the metallurgical limit. Okay, when the maximum temperature is fixed by this limit as the operating steam pressure at which heat is added to boiler increases, P1 to P2, the mean temperature of heat addition also increases. P1 to P2, mean temperature of heat addition, mean temperature of heat addition also increases. Right? The mean temperature of heat addition also increases. So the efficiency also increase. Okay. Therefore, with the maximum steam temperature at the turbine inlet, the minimum, very important, maximum steam temperature at the, write down, with the maximum steam temperature at the turbine inlet okay, at the turbine inlet the minimum temperature of heat rejection okay, তাহলে minimum temperature of heat rejection. Now তাহলে minimum temperature of heat rejection, so the efficiency automatically increases turbine and the maximum steam pressure at the turbine inlet also get fixed. The vertical line drawn from state 2 to fixed temperature T2, another one, fixing the maximum steam pressure at turbine inlet, another one diagram. This is the temperature, this is the S entropy, TS temperature entropy. So another one diagram. Okay, তাহলে 1 2 3 4 this is the P1 max, this is the T max, okay. So the vertical line drawn from state 2 fixed by T2 and X2 intersect the Tmax line at state T1, which gives the maximum steam pressure at the turbine inlet. Okay, another one is the reheating of steam, very very important, reheat again, heating again and again, okay, that is the reheating. তাহলে reheating of steam, reheating of steam. তাহলে if the steam pressure is higher than P1 max is used in order to limit the dryness fraction 0.88 at turbine exhaust, the reheating of steam has to be adopted. In that case, all the steam after partial expansion in the turbine is brought back to the boiler and reheated by combustion gases and then fed back to the turbine for further expansion, okay, for further expansion. So first one, you draw the diagram first. This is the pump, okay, this is the condenser, this is the turbine, another one line goes to that side, another one, here is the superheater is there, then again back to turbine, okay, back to turbine. One is the middle turbine, that is the high pressure turbine, okay, middle turbine. This is the HPT, high pressure turbine, and that is the LPT, low pressure turbine, and these two are connected Okay, then this one, this one goes to this, and like that. Okay, this is the reheat. This portion is the reheater, again and again heating, RH. Okay, this is the SH. Okay, RH, SH, and this is the flue gases. Flue gases. One is the flue gas, another one is the exhaust. So one is the flue gas, another one is the exhaust outside. Exhaust. Okay, so that is the 6s, that is the 5, that is the 4s turbine, LHPT, LPT, that is the 1. Okay, and that is the A and B. Okay, like that, and that is the part 3. Part 3. Okay, that is the 2s. Okay, that is the 2s, and this one is the boiler. Boiler. Okay, like that. Now, first one, in the first step, steam expands in the high pressure turbine from the initial state to some intermediate pressure. Process 1 to 2s. 1 to 2s. Okay, so steam expands in the intermediate temperature 1 to 2s. Okay, okay, now okay, reheating of steam pressure. So next day we discuss this topic again.